All right, so good. Okay. So a dilation is a change in a figure's what? What would you describe that as? The size, right? Because we are enlarging the shape or shrinking the shape. So we're changing the size of the figure, but not in a figure's what? Shape. We're not changing the shape of it. We're not changing it from a squirrel to a star, right? We're changing it from a squirrel to a smaller squirrel, or a squirrel to a larger squirrel, okay? Not really sure why I chose squirrel, but, you know. Okay, so how does this compare to what we talked about last unit? Last unit we talked about what? Translations, rotations, and reflections. Okay, and how did we describe those shapes? As congruent. Okay, yes, sliding it across, reflecting it, or rotating it. But we described it as congruent. What did we define congruent as? Same shape or same size, but different what? Location. But this time we're going to call these similar shapes because they have different size but same shape. Okay? So this is how you find, I want you to add this, to find a scale factor. We're going to compare new and old shapes. We're going to compare images and pre-images. Okay? So I'm going to say that this is the new divided by the old. But how else could you describe the new? The new shape. Nope, new shape. Is that the pre-image or the image? Image. Okay, so new or the image, old or the pre-image. Very good. Okay, so that's to find the scale factor. Okay, so that means if I give you two shapes and I want you to find the scale factor itself. Okay, now a scale factor of less than 1, and I want you to also add greater than 0. If a number is greater than 0, what does that tell you? It has to be positive. So we want a positive number that is less than 1. Okay, if a number is less than 1, what does that tell you? Less than 1 and greater than 0, what does that tell you? Can't be negative if it's greater than 1. It's a what? It's a fraction or a decimal. Very good. So if we have a fraction or a decimal, then that means that we're going to have, what do you think, an enlargement or a reduction? Reduction. We're reducing it by 1/2, 1/4, 1/6, 3/5, something like that. So that means we're going to have a reduction. Okay? So a scale factor of less than 1 or greater than 0, then you're going to have a reduction. Okay? Then number 2, a scale factor of greater than 1 means that you're going to have a increase or an enlargement. Very good. Enlargement. Okay? So if you have a number that's greater than 1, you are going to have a scale factor of 6, 10, 100, 1,000, 2.5. Okay, then that means you're going to have an enlargement. But what if we have a scale factor of 1? What do you think that means? It's whole, yes. It's going to stay the same. Okay, what happens when you multiply any number by 1? Stays the same, right? Whether it's negative or positive. So if you have a scale factor of 1, that means we're changing it by 1. Nothing's happening to it, right? Okay, it's just itself. So that means that you have the same shape. Same shape, same thing. Okay, same squirrel. Again, don't know why I'm choosing squirrels, but it's fine. All right, so let's actually do a dilation. Okay? So now let's graph triangle STU with those vertices. S is at -1, 2, T is at 4, 0, and U is at -2, -4. Okay? So let's go ahead and plot those points. And I'm going to do triangle STU in blue to keep them separate. So S is going to go at -1, +2. Make sure you label all of your points. Okay. T is going to go on the y-axis or the x-axis? The x. This is x, this is y. So we're going to go over 4. So that's going to be T. And then U is at -2, -4. All right, make sure your points are labeled. Do you have a question? No? Okay. All right. Got those? All right, now let's do our dilation. Okay? So we're going to dilate triangle STU using a scale factor of 1/2. Okay? So that means we are going to shrink it. Is it going to be a reduction or an enlargement? A reduction. Okay, so number 5 says, is it a reduction or enlargement? I want you to circle reduction. Okay, number 5. Oops. I went too far. Okay, number 5 says it's a reduction or enlargement. I want you to circle reduction because it's a scale factor of 1/2. All right, so here's how we're going to perform our reduction. Okay, so we've got S here, T here, and U. Oh, I have it wrong. S should be at -1, 2, right? Okay, that's what I did wrong last time too. U. All right, so here's our triangle. Did you connect the points? Go ahead and connect the points. Okay, so S is at -1, 2. And we are going to multiply that by our scale factor. Okay, we're going to multiply that by our scale factor. Do you think I'm going to only multiply the x point by 1/2? We're going to multiply both because it's affecting the entire point. It's not just going to affect the x or the y, it's going to affect the x and the y, okay? So the 1/2 is going to get multiplied to the 2 and to the -1. So that S prime is going to be -1 times 1/2, which is what? -1/2, right? -1 times 1/2 is -1/2. And then 2 times 1/2 is 1. 1/2 of 2 is 1. Okay, so there's my new point, -1/2, 1. So I'm going to go over -1/2, up 1, and plot my new point, S prime. And make sure that you're labeling all of your points so you don't get confused. And now we're going to take T. T is 4, 0. We're going to multiply it by 1/2. So 1/2 is going to get multiplied by the x and the y values. So that's prime. 4 times 1/2 is what? 2. Very good. 1/2 times 0 is still 0. Okay? So T prime is going to shrink in to 2, 0. Okay, and notice that there's the space that you can write in the new points on number 4. Okay. All right, then we've got U, and U is currently at -2, -4, and we are going to multiply that by our scale factor, which is 1/2, so that T prime, 2 times 1/2 is going to be -1. -4 times 1/2 is, what's half of -4? -2. Ma'am. Oh, thank you. Whoops. Yep, that definitely should be u prime. Thank you. All right, so -1, -2, that's my u prime. Then connect all your points. Okay, and does it look like we have reduced it by a factor of 1/2? Have we reduced the amount of space by 1/2? Yeah. Okay. We already said that it's a reduction because the fact that what? What makes it a reduction? It's getting smaller. And how did we know before we even drew it that it was going to be a reduction? The scale factor was less than 1. Very good.